Let's go ahead and give this problem a try where we're going to relate the area of a sector to the arc length of a given circle. In circle N, we know that segment NO is going to be equal to 8. And notice that that's the radius of the circle, so that's pretty important. Then we're told that the area of the shaded sector is 8 pi, and that's this area right over here. What we're being asked to do is to go ahead and find the length of arc OP. That's going to be from here to here. So we're given the area of a sector, which is related to the area of the circle, and we need to go ahead and use that information to relate that to the arc length, and that deals with the circumference of the circle. So since we're given information about the area, let's go ahead and start with that first. We know the area of a full circle is going to be pi times r squared. In this particular case, we know that the radius is going to be 8, so it's really going to be pi multiplied by 8 squared, right? Let's go ahead and write that in. Now if we go ahead and just simplify this a little bit here, we know the area of this full circle is going to be 64 pi. Now what's the area of the sector? Well, the area of just the sector that we're given here is going to be 8 pi, so that's going to be part of the entire area. So if we want to go ahead and write a relationship between the area of the sector and the area of the entire circle, we can go ahead and say that we have this 8 pi out of the 64 pi, that's the area of the entire circle, and this could be written as a proportion if we want to think about what the angle measure is, because maybe finding the central angle may be helpful here. So let's go ahead and write 360 degrees, and let's go ahead and say that we don't know the central angle, so x is going to represent that. So in the circle, I'll just go ahead and say this is x degrees. And if we go ahead and simplify and divide both top and bottom by pi here, as well as divide top and bottom here by 8, we can go ahead and simplify this proportion and say this would be 1 over 8 is equal to x over 360. So that might be a little bit easier to think about. Then we can go ahead and just use cross products if you'd like. So if we use cross products here, we would see here that 8x would be equal to 360. And then dividing both sides by 8, we would find out that x is equal to 45. And so from this, we just found out the central angle is going to be 45 degrees. That's going to be this angle right over here. Given that we now know what the central angle is, I think we can go ahead and use this information to find out that arc length of OP. So remember, arc length is really just part of the circumference, so we're going to deal with the circumference idea here. Let's see what we know here. Well, we do know that the circumference of this entire circle would be 2 times pi times the radius, and we do know that the radius is going to be 8, so this would be 2 multiplied by pi multiplied by 8. So the entire circumference here we know is going to be 16 pi. That's all the way around the circle. And what are we going to say that we do know that we can relate to this? Well, we do know that the central angle is 45 degrees. That opens up to this arc length, and that's out of the full circle of 360 degrees. Now, the full circle circumference is going to be 16 pi. And so if we know that 45 degree angle opens up to that arc length, let's go ahead and let y here represent that arc length of OP. Now we know this 45 degrees over 360, we can divide both of those by 45. So really we know that this is 1/8 of the entire circle. So we know that the arc length actually has to be 1/8 of this 16 pi, right? Now you can go ahead and use cross products here and multiply if you'd like to, or you can know that y would be 2 pi. It's totally up to you here, but we can go ahead and say here that 8y would be equal to the 16 pi. If you go ahead and just use the cross products and write an equation and have no fractions there. And then we can go ahead and divide both sides by 8 and say that y would be equal to 2 pi. And so in conclusion, we can say that arc OP is equal to 2 pi.